Hello, in this lesson, we will learn how to name binary ionic compounds. Binary ionic compounds are those compounds which are made up of one metal, monoatomic metal, and one monoatomic non-metal. So both metals and non-metals can be found in the periodic table. This is a good thing. You don't need to memorize the complex anionic formulas. Both cation and anions are present in the periodic table. And you normally during the cycle exam, you have the periodic table in front of you. So all you need to know is that how to find the metals and non-metals in the periodic table and know their charges. For example, if you have sodium chloride, sodium, the cation is also in the periodic table, and chloride, the anion, is also in your periodic table. Now, if you're given any ionic compound name and you want to write the formula, this is the first step. You write the cation with the charge on it and anion with the charge on it. And then there are two ways to write the formulas. This is the first way. Simply know that what is the ratio of cation anion, because here sodium is +1 and chloride is -1. So both are just 1, 1. So you can just put them together and they come close, cancel each other's charge and become NaCl. So NaCl is the ionic formula for the sodium chloride. But in case of calcium chloride, calcium is 2 plus and one chloride cannot cancel 2 plus. So we need, so if you bring them together, 1 minus 1 of chloride ion can cancel maybe +1 of calcium, but still +1 is there. So we need 2 chloride ion. And that's why calcium chloride is CaCl2, while NaCl is only NaCl. Now, if you're really beginner, you want to know that how do we know that what is charge on metal cation, like sodium was +1 and calcium is 2 plus and magnesium is what, aluminum is what, and what is the charge on anions, for example, oxygen, sulfur, chlorine. So if you're that beginner, so you want to use the periodic table in this way. I'll show you. This is the periodic table. The vertical columns are called groups. The main group elements are the S block and P block, not the middle one. The first two groups are the S block, and leave the middle one, and then last 6 groups are the P block. These are called main group elements. Now, the very first group, metals other than hydrogen, which is not a metal. So all the metals in the first group, when they make ionic compounds, they become cation with +1 charge. All right. And similarly, the group 2 elements, beryllium, magnesium, calcium, all they become 2 plus. In group 3, normally we only take aluminum from there. That is 3 plus. So whenever aluminum is there as cation, you write 3 plus on top of it. So these 3 groups, group 1, group 2, and group 3 will make cations. How about anions? Now start from the other end, leaving behind the noble gases which don't react. After that, the first group is -1, like fluoride, chloride, bromide, all they are -1. And from the right side, the second group is oxygen, sulfur, they are -2. And the nitrogen and phosphorus, they are -3. One worth remembering fact is that when you write the names of the ionic formulas, the cation keep their name. For example, sodium remains sodium, magnesium remains magnesium, but anions change their suffix as IDE, like fluorine becomes fluoride, oxygen becomes oxide, nitrogen becomes nitride, phosphorus becomes phosphide. So anions change their name with IDE, but cation, they keep their name. Now, to summarize this periodic table, any element from the group 1, like lithium, sodium, potassium, if they are there, you always write +1 on top of them. So you know that this is all these metals are +1. Any metal from group 2, beryllium, magnesium, calcium, strontium, if they are there in the ionic name, they are 2 plus. All right. Normally from the group 3, we only take aluminum or maybe sometime boron. They are +3. And then from the anion, minus ones are all these halogens like fluorine, chlorine, bromine. When they become anion, they become fluoride, chloride, bromide, like they end with IDE. Similarly, then we have oxygen and sulfur. When they become anion, they become oxide sulfide with -2 charge, and nitrogen and phosphorus, they become nitride and phosphide. All right. So once you know their charges, it's really easy to write the ionic formulas for the names given to you. Um, so let's have some practice questions. First example is, let's say, magnesium chloride. Um, Magnesium is the cation, we know that, and chloride is the anion as it ends with IDE. So all we want to do, look at periodic table. Magnesium is present in the second group, so we write here as Mg and 2 plus. All right, and chloride is Cl minus. Um, from the concept, from the understanding, we already know that Mg is 2 plus, chloride is -1, which means that we need 2 of the chlorides to balance the charge. But there is another way. We can use crisscross method. Now, crisscross method means the magnitude of the charge, just the number 2, it goes there as a subscript of the chloride, and 1, because chloride is -1, 1 comes here as magnesium, and 1 we don't write. So the formula will become Mg, which is 1, we don't write it, and Cl2. So this is the ionic formula of magnesium chloride. So this is really easy. It's called crisscross method. Now we'll see another example. Let's see two more examples. The first example is aluminum oxide, and we know that from the periodic table, aluminum is in the third group. Aluminum with 3 plus, and oxygen is 2 minus. All right. So once we write the cation and anion, looking at periodic table, simply crisscross. Take the 3 of aluminum as subscript of the oxygen, and this 2 of oxygen goes there as aluminum subscript. It becomes Al2O3. Easy. Aluminum oxide. So the name is aluminum oxide. We keep the name of cation, and the anion oxygen becomes oxide. So name is aluminum oxide. All right. So we don't change the name of the cation, but we change the name of the anion to IDE form. Now, similarly, we have sodium oxide here. So sodium is Na plus 1. We don't write 1. Oxygen is 2 minus. Yeah. Now, this 2 crisscross method, this 2 goes there and 1 goes there. 1 we don't write. So Na becomes Na2, and oxygen remains 1. So this becomes sodium oxide. Let's do few. I'll give you a few more names, and you try to write the ionic formulas, and then check when I write the answers for that. All right, you can hold on and try to write the ionic formulas of these ionic compounds, and you have 5 minutes to finish this, and then resume your video, and you can see answers. All right, now you can check your answers. You can see that we use the same crisscross method. For example, I'll just show you one, maybe because in case of BA was 2 plus and nitrogen was 3 minus. So this 3 goes there and this 2 goes there, and we get this formula. So I applied same crisscross method for all the ionic compounds and got these formulas. So check with your answers. If you did not understand, watch this video again. I hope it will make more sense. Thank you.